So today we are going to see about Cauchy's linear differential equation. So this is the problem. Solve x square d square minus x into d plus 1 into y equal to x square plus 1 by x square. So first of all, for this problem you have to make some substitution. So that is, you have to put x into d equal to d dash and x square into d square as d dash into d dash minus 1. So this is the substitution you have to make in the left hand side. For the right hand side, you have to substitute x equal to e power z. So if x equal to e power z, if you take log on both sides, what you get? Log x is equal to log of e power z. So log and e gets cancelled. So you get z. So in the right hand side part, you have to put log x equal to z and x equal to e power z. So wherever you are having x, replaced by e power z, and wherever you are having log x, replaced by z. Similarly, in the left hand side, you have to replace x into d to be d dash, x square into d square to be d dash into d dash minus 1. Okay, let me get into the problem. So this is our question. So x square d square. So what you have to substitute? For x square d square, you have to substitute d dash into d dash minus 1. So that I have substituted. And minus, so what is our x into d? So x into d is nothing but d dash plus 1 into y equal to our right hand side. So right hand side we are having x square. So x square is nothing but e power z the whole square plus 1 by x square, that is 1 by e power z the whole square. So after the substitutions are made, you have to simplify this problem. So you multiply this d dash into d dash as d dash square minus d dash into 1 is d dash, and here you are having one minus d dash plus 1 into y equal to e power z the whole square. So when you multiply these two, you get e power 2z plus similarly 1 square is 1 divided by e power z square is e power 2z. So in the next step, it is simplified as d dash square minus d dash is nothing but minus 2d dash plus 1 into y equal to e power 2z plus, when this comes to the numerator, it will be e power minus 2z. So after this simplification, you keep this as it is, and for this problem you have to find the complementary function and particular integral. Let me find the complementary function. So what I told in the previous class itself, so complementary function is nothing but you have to replace d dash by m. So here it is m square minus 2m plus 1 equal to 0. So this is nothing but m minus 1 the whole square. So when you find the roots, you will be getting m equal to 1 comma 1. Here the roots are real and equal. So for real and equal roots, what is the complementary function? Cf equal to az plus b into e power z. So our z can be replaced by log x and e power z can be replaced by x. So that is our next step. So this is our complementary function. So Cf is a log x plus b into x. Next, let us find the particular integral. Here we have two functions, e power 2z and e power minus 2z. So first let us find e power 2z. That is particular integral 1 is nothing but e power 2z divided by d dash square minus 2d dash plus 1. So this comes under type 1. So how will you calculate type 1? So in type 1, we have to replace d dash by the coefficient a, where our a is nothing but our 2. So d dash you have to replace by a is nothing but the coefficient of that is 2. So if you replace, what you get? E power 2z divided by d dash square is 2 square minus 2 into 2 plus 1. So 2 square is 4 minus 2 into 2 4 plus 1. So 4 and minus 4 gets cancelled. So our answer is e power 2z by 1 is e power 2z. So final answer you have to give in the form of x and y. So e power 2z can be written as x square because e power z is x. So e power 2z is nothing but x square. Next, let us move on to the particular integral 2. So Pi2 is nothing but e power minus 2z divided by d dash square minus 2d dash plus 1. Similarly, here the coefficient of z is minus 2. So you have to replace d dash by a, that is by minus 2. So when you replace, you get minus 2 the whole square minus 2 into minus 2 plus 1. So minus 2 the square is 4, minus into minus plus 2 2s are 4 plus 1. So e power minus 2z by 9. So when you bring this e power minus 2z to the denominator, it becomes plus. So 1 by 9 e power 2z. So e power 2z can be replaced by x square. So So particular integral 2 is nothing but 1 by 9 into x square. So finally the general solution is nothing but you have to sum up the complementary function plus particular integral 1 plus particular integral 2. What is our complementary function? So here it is. So a log x plus b into x. I have written this plus particular integral 1. So particular integral 1 is nothing but x square plus particular integral 2, that is nothing but 1 by 9x square. So this is our solution. Hope you understand. Thank you.